Hi guys, let us talk about the slookup function, or in this case, just to S is just for stochastic lookup. So it's kind of like similar to the VLOOKUP and HLOOKUP in Excel, but then we will use the lookup function in a different way, in a random way or stochastic way. Okay, so let us start with this distribution. So you have blue with 30%, green with 20%, and then red with 50%. If you visualize this table in ggplot, and then you can see here you have red is the highest, and then highest, and then the blue is lowest one. Okay, so in our script language, and then you just use this function. You just use C function and then use blue and green and red in order to specify this, and then you can just use the data frame for ggplot to work with. Okay, so that's how you visualize the first two part. Okay, so now I will show you how to perform the stochastic lookup function by using the replication. Okay, so in here I will show you, I will replicate the blue with 3, which is like 30%, replicate green with 2, which is 20%, and then red with 5. So we have the lookup function, another lookup function, or another lookup array, which 2, 3, 5, and then it looks like this when I remove the hashtag here. It looks like that. Okay, so let us wait for a while, and then the result will come out, and then there we go. So the array is from 1 to 10, and then for the first three we have 30%, which is blue, and then 20%, which is 2 columns here, and then we have green, and then the other one is red. Okay, so this one is there's no big deal from here to here. It's just like we have more columns for the concept or the color with more width. So in this case, I just choose 3 and 2 and 5, and then you have this sum to 10, so you can just divide 10, and then you have 3 columns, 2 columns, and 5 columns. Okay, so that is just to transform this modal or non-uniform distribution into the uniform one. Okay, so the next thing is just to randomize this column. So basically, when I generate a value between 0 and 1, and I multiply by 10, and then 0 and 1 becomes like 1 to 10, and then I just color by this number. So for example, like if I have 0.4, I sample like 0.41, and I multiply by 10, it becomes 4. I have to use a cell function. If I use a cell function, then it will become 5, so it becomes red. That's what I'm going to do, and that's what slookup means. And I show you the table first before I explain the concept. Okay, there you go. So assuming that I generate the first value, which is 0.28, and then the position here will be 3. So if you have this, you apply the ceiling function and multiply this one by 10, and then apply the ceiling function, and then you have 3. 3 will be here, and then you have the color blue. So similarly, if you apply this one 0.78, you multiply by 10, it will come, and then applying the ceiling function is, it will go 8, and then because 8 is here is red, and then you can translate by red. Okay, and then so on. So basically you just generate a random number between 0 and 1, and then you round the number so that it fall into those one of those buckets, and then you look up the values and then you have the color. So that's this is mainly this is the like the main idea of stochastic VLOOKUP. So you just use a random number to look up for the name. Okay, so at the end of the day, what you get? You get the distribution like this. If I visualize this table in another chart, and it look like this. So you can see here there are fair amount of okay, let me start with the value here, the value which is like from 0 and 1, and then the POS which is a position here from 1 to 10, and in here I just display the numbers here so you can see that this is 1 2 and 3 4 5 6 7 8 9 10, and then the color will be based on this this scheme. So from 6 to 10 will be color red, from 4 to 5 and will be green, and then the rest will be blue. Okay, so if you have this kind of arrangement, then you can see actually this is how it works to if you count the point in order to obtain the original distribution. So for example, if you count everything from 0 to 3, 0.3 here, this one is about 0.3, so 0.25 here, so 0.3 is here. So if you count all the point below 0.3, you will get green, and then eventually you get back to this one. So if you count everything from 0.3 to 0.5, you will get green, and then it will tie back to the 0.5 minus 0.3 will be 0.2, and then you get back to this distribution. And similarly, if you count everybody from 0.5 to 1, you will get this red distribution, and then you tie back to this one. So this is very simple example, but it shows the nature of sampling transforming the uniform distribution to the modal distribution. So you can see here, if everybody is uniform from 0 and 1, but then after you transform this using the VLOOKUP function, and then actually not VLOOKUP, is slookup function, and then you can use you can end up with the original distribution like this. Okay, so that's the first lesson from this exercise. The second one is, you can see here in this case, if you use 0 0.3, 0 0.5 and 1 as the upper bound, and then you can color also. So for example, if you color everybody from below 0 0.3 will be blue, other than that 0 0.5 will be green, and then 1 will be red, and then you end up with the same result as well. So this will be this is called the transformation method, which is a different method for transforming the uniform distribution into the modal distribution or the non-uniform distribution.